Hi everyone, I'm Cheryl. In this problem, we're given a function of three variables. Our function is f of x, y, and z equals 4x squared plus 9y squared minus 4z squared. We're asked to describe what the level surface 4x squared plus 9y squared minus 4z squared equals 0 looks like. So to get an idea of what this surface looks like, we're going to look at some traces. So we'll begin with an xy trace. And for an xy trace, we're going to try a couple of different traces. We'll look first of all what happens when z equals 0. When z equals 0, my equation turns into the equation 4x squared plus 9y squared equals 0. This is actually just a point, because the only value that makes this equation true is the point where x equals 0 and y equals 0. All right, that didn't give us a lot of information, so let's try another trace. Let's see what happens when z equals 1. If z equals 1, my equation becomes 4x squared plus 9y squared minus 4 equals 0. This is going to be an ellipse. So if I'm looking at something parallel to the xy plane, my graph is going to look like an ellipse. All right, so let's go ahead and look at some other traces. This time, let's look at the xz trace. And again, there's several traces I can look at. Let's begin by letting y equal 0. If y equals 0, my equation is going to look like 4x squared plus 0 minus 4z squared equals 0. Now, if you solve this, we're going to end up with x being equal to plus or minus z. That's basically two lines that are crossed as an x. Well, let's get another trace just to kind of have a sense of what's happening. Let's see what happens when y equals 1. When y equals 1, I'm going to have 4x squared plus 9 minus 4z squared equals 0. This is a hyperbola. So that's the equation of a hyperbola. Remember what a hyperbola is. It's one curve this way and another one that comes down this way. All right, so that's what's happening on the xz plane. Let's take a look at the yz plane. So we'll look at a yz trace. And again, I'm going to look at a couple of different traces. Let's start out with the one where x equals 0. If x equals 0, my equation reduces down to 9y squared minus 4z squared equals 0. And if you solve this for z, you're going to end up with z being equal to plus or minus 3/2 y. And again, that's going to be two lines that are crossed. All right, let's try one more trace. Let's see what happens when x equals 1. If x equals 1, I'm going to have the equation 4 plus 9y squared minus 4z squared equals 0. And again, this is a hyperbola. So what does all of this tell me? Well, I know that in the xy plane, so I think of the surface that's flat, I'm going to have an ellipse. And if I look in the xz plane, so the one that's coming out toward me, I'm going to have an x, and then sometimes there'll be hyperbolas as well. And if I look on the yz plane, the same thing will happen, as I'll have an x, or two diagonal lines that cross, making an x, and also some hyperbolas. So what does that look like when I graph it? Well, a rough sketch would show me that that's going to look like what we call an elliptical cone. And you can kind of see the traces when you look at this elliptical cone. So first of all, from the XY perspective, you have these ellipses. And right there's the point. That's what happened when I tried the trace when z equals 0. Okay? If you're looking at the xz trace, that's the one that's coming out towards us. You can see the two lines that would be crossing to make that cone. And you can also see that if you slice it further out, you'll get part of a hyperbola, one piece here and the second piece down here. It might be even easier to see that though with the YZ traces. So in the YZ trace, you can see here's the cross, and the hyperbola that you're going to see if you cross it is going to look, there's the top half, and here's the bottom half. So you can see that all this information together gives me this surface. I hope that was helpful. Thanks.